morning, good afternoon, good evening. We are at episode number 39, miraculously, of the Unboxing AI webinar series. And once again, this is one of those episodes where you get to see only me. And yes, it is extremely lonely. So, yes, I appreciate all questions coming in. For those of you who don't know, this is the Unboxing AI webinar series by CARPL. We every Thursday now, every Thursday, 11 a.m. Eastern time, you will see me normally with someone, with a customer, partner, vendor, or just friend, pontificating about the world of AI. But yes, we are doing a few sessions where we thought it might be useful to just talk a little bit about CARPL, about why we do things, how we do things, go a little deeper into the various offerings that we have as a platform. In case you don't know what CARPL is, have you been living under a rock? Well, we are your friendly neighborhood AI marketplace, AI platform, enterprise imaging AI platform. We've been called many things, but at the end of the day, we are the middle layer between the world of AI out there for clinical applications and your clinical radiology workflows, allowing you to build, test, deploy, and monitor all sorts of radiology AI systems, eventually being consumed within healthcare providers through a single user interface, a single data channel, and a single procurement channel. And today is the third episode in the DevD series that we're running. And as is customary, please do not hesitate at all to ask me anything. As I do this, you can use the chat box, you can use the Q&A feature, you can text me, whatever you'd like. So with that, I am going to share my screen and go a little deeper. So at CARPL, we are simplifying the adoption of radiology automation, of radiology AI. I'm sure many of you would know that by now. At a very high level, we are doing nothing but connecting AI applications with healthcare providers, improving the access, affordability, and quality of medical care out there um, today. That is the proverbial triple aim of healthcare, and we believe that AI is finally the that technology that can help affect all three axes, improving them exponentially. We are the world's largest AI marketplace. I think now we have 154, 155 applications from 66 odd vendors. Uh, we are the only platform out there allowing you to build, test, deploy, and monitor AI in clinical workflows. We are the only ones that are FDA approved, FDA cleared, as our regulatory team often reminds us, and CE marked. We are the only ones out there. We are the only ones to have a universal AI widget on 20th of February. I'm going to be talking about that. Be sure to tune in. And have the privilege of being used by some of the world's top radiology groups. Something that IT teams really like is the fact that we are infrastructure agnostic. We can run on-prem, on cloud, on private cloud, on public cloud, anywhere in the middle, hybrid, what have you. We are addressing the simple problem of there being an expanding demand-supply mismatch in radiology globally. AI algorithms that are being built to automate or to augment the work of the radiologists are not being used. Because healthcare providers find it impossible to navigate this ecosystem. You have to, these AI solutions are very difficult to access. We talked about some of that in the session before last. Very difficult to assess. We will talk about this today, how one should go about assessing AI. And then maybe the most complex piece is the integration with the clinical workflow piece, which is extremely difficult to do. In the end, it's a platform approach that combines all of these elements, is what we hypothesize as the only way of unlocking exponential value from these AI solutions. So DevD is the name of the webinar and DevD is the title of the slide. So should give something away. I already have Q&As. Wow, for later. Very nice. Thank you, guys. I appreciate it. So Dev D is a subtle take on the Indian movie Devdas, for those of you who may know. But uh, DevD is a two-step sequential process that we have created for effective deployment of AI within clinical workflows. Dev stands for Discovery, Exploration, and Validation of AI. In the first session in this series, we talked about the discovery layer. If you've not checked it out, I'm sure the link would be somewhere here in YouTube, around here. Do check it out. It would give you a lot more context around today's session. Then comes the process of exploration of AI, taking a little bit of your own data, running it through multiple AI systems, trying to get a sense of the value that an AI application can provide. And then exploration is followed up with deep statistical and clinical validation of AI systems, which is what we are going to be talking about today. The outcome of the dev process is the deployment of these solutions in clinical workflows, which is going to be the session on 20th of February. Next week on 13th, we are going to be having Dr. Harry Jha, Saurabh Jha from the University of Pennsylvania, somewhat of a celebrity. So he agreed to do a session with us. So that's very, very exciting. All of the above is possible because of CARPL's modular architecture. There's a bunch of things that we do. Maybe one day we will do a tech webinar and go deeper into some of this stuff. So just a word about the importance of pre-deployment validation through a platform approach, right? Let's just examine for a second how AI validation studies or AI pilots are done today in healthcare providers across the world. Well, typically, let's say you're a chief medical officer, chair of radiology, CMIO, chief AI officer, what have you. You need to, prior to piloting something, make a decision to pilot that application. The first thing that happens is the providers, the radiology groups, clinical leadership has to invest time in engaging with the AI company, right? Let's say you have built a tool for automated detection of stroke on CT scans. Someone has to have a conversation for the provider to know that you exist. And then, typically they will review demos, read research papers. There'll be a couple of conversations involved. And then there are internal meetings to figure out whether or not to even proceed with this pilot. And once you've decided to pilot is when you start getting into architecture reviews, security reviews, legal reviews, all with that one AI developer. And then a commercial team comes in, gets involved to figure out the scope of the pilot, what happens after the pilot, creating a business case, so on and so forth. And then, of course, there's a project manager who's designated to make things happen, right? Engage on both sides, to stakeholder management, all of those fancy things. Once all of this happens is when you need to provision infrastructure for the AI algorithms to run, right? AI cannot run without compute. So somehow in your institution, you will need to figure out some bespoke compute requirement that eventually will run the AI and thereby enable the pilot. Once you have provisioned the AI infrastructure is when you then have to do integrations. You will have to integrate with the risk packs, right? You somehow need to receive data. You may need to want to send outputs, right? How does that happen? Well, you integrate. You need to de-identify data and you need to check for whether the de-identification even works or not. Again, something that you would need to do every time you want to evaluate a different AI system. And finally, at the end of all of this is when your clinicians are able to review some of these AI outputs. Some challenges there. Every AI company out there has a different viewer, has a different way they want to show you the outputs. You would need to learn to use those. You would need to review each AI algorithm separately. If you're testing out four different chest X-ray vendors, you would need to do the reading at 4 times. And of course, there's no standardized feedback templates, no standardized nomenclature, and that makes it very difficult to compare these AI systems. Of course, CARPL makes you have to do this once with CARPL. I'm not saying you don't have to do it once. You have to do it once with CARPL, but then never have to do it again as one goes through the process of AI validation at scale. So in a nutshell, from a validation perspective, CARPL makes the incremental cost of AI pilots zero. And yeah, that's the value of validating on CARPL. This is what the platform looks like. I will quickly jump into a demo, but at a very high level, it's a single user interface for all your AI validation. Doesn't matter what body part, what modality, what pathology, what AI. We are agnostic. You can use this for everything. You can compare AI solutions. You can ensemble AI solutions. We'll go deeper into what that means. You can do bias and fairness estimation as well on the same platform. One of the key reasons why one has to do AI validation is because it can work really well at your hospital, not as well at my hospital, because you've got a GE machine, I've got a Philips machine, and the AI was trained majorly on GE data. So again, very important aspect of validation. Then, of course, sometimes you just want to see metadata-based analysis. You want to see, okay, how did the AI perform on men versus females? Or how did the AI perform on certain, BMI levels of individuals? So very important to be cognizant of the sources of bias and, address them as you validate. Now, I am just going to check out. Okay. Yes, we have those two questions that we can take in a bit. So this is what CARPL's validation platform looks like. As I mentioned at the beginning, we are infrastructure agnostic. So what that means is you can take this entire validation platform and run it within the confines of your own, health system in your office, at your radiology department, wherever you would like it. We are very, very flexible in terms of how we deploy. In terms of the algorithms, I think I covered this earlier. This is our algorithm menu. The validation piece important here is that, let's say you're an academic center, you're building your own AI, you can add that to the platform, to your specific instance of the platform as well, and thereby compare the performance of your model to commercially available models out there as well. So yes, moving on, the way validation happens is you can typically create a workflow on CARPL. So I'm going to say demo webinar, create a project. Now, you create a data set. So everything starts with data, and, then you create what is called a testing and monitoring project. You link up an algorithm to it. You also have a deployment project associated with it. Yes, so now you can basically link all of these up. And the algorithm goes here. Algorithm can also go here. And now what happens is, as we go about and publish this, and of course, you can choose multiple algorithms and connect them to the same testing project. This is how you can just choose your algorithms. We've got all these here. And as soon as you save this as a draft and then you publish it, I haven't selected any algorithms, so I'm not sure if it'll actually work. But the whole idea is that once you have this set up, you can then go into a data set, right? So you can, the demo webinar data set is here. You go in, you can load your own data. So the whole idea is to do the validation on your own data. You can upload a folder of DICOM images. You can upload individual files. You can even do in-browser anonymization. if you'd like, you click a button and all the metadata gets stripped, um, amongst many other features. This is once data comes into this data set is when it then goes into a deployment project. In the deployment project, we have, like, as you can see, this is the team. They've made a bunch of projects. So you create a deployment project for the AI that you want to test, right? So you can create a project. You can say, okay, this is the demo webinar project. You can select a feedback template. We provide them. We provide a few by default, and others, you can create yourself. And then you select an algorithm. Pneumonia detection is Checkspert. You select a data set. I select the demo webinar data set. I can do study description filters, in terms of including and excluding studies, what have you. And then I create the deployment project. Now, any data that comes into that particular data set comes here, AI starts running on it, and then I link it to a testing project here, right? Again, I create that project. I would not need to do it if my workflow was set up, initially that we started. Then again, this is the demo webinar project. I can import from a deployment project. I go next. I select, whatever project I want. I think it was the webinar project, so the demo webinar. Next, and I create the validation project, and that's how the system works. An example of a validation project that we have already. Check and refresh. It should come up. Yep. So basically, this is an example of what the validation project would look like in steady state. You have 1,000 studies loaded by the user. They selected 4 different AI. So in the workflow module, they selected 4 different AI. They also loaded the reports. So that is something I did not cover. I'm going to quickly show you. So here you can even add reports to your data. So you can download a CSV file uh, onto your computer, paste all the reports, upload the files, and that becomes important because if you see here, we need to go from report-based ground truth to finding-based ground truth. So here what we have done is we have used a large language model that runs in the backend to convert a report to a finding. In this case, it is simply normal versus abnormal, and we get automatically populated AUC values for each of these AI. These are 4 different commercially available AI algorithms. Unfortunately, I can't open them up in public. Maybe I'll show you a couple of cases. And our friends won't mind. But the whole idea is that you can, with a single click, with a couple of clicks, get to AUC value very, very fast. You can even ensemble these AI systems. So the way we've ensembled right now is to use a max filter. I'm just going to open up one of these scans. So if you see here, AI01 has said 89% probability of abnormal, 02 has said 85%, 03 said 80%, AI04 said 99%, and the ground truth also says yes, there is an abnormality in this scan, and we can open up all of the AI outputs, and we see that pretty much all of them have given the same output. We can even see the report that is there for this scan. I think that was a false report, but the whole idea is that using a single platform, you are able to get summary statistics. You are able to get to down to the image and see which AI you like amongst those that we have. Moving on in terms of features, you can sort a lot of them. You even get your sensitivity, specificity values here. You can change your thresholds to adjust for your clinical scenario. Like right here, this is one false negative. The ground truth says, yes, there is an abnormality. All the AI systems said, no, there is no abnormality. So, you can open it up, you can check it out yourself, so on and so forth. Then you can even get one-click performance reports. You click a button, out pops a report. for your chosen threshold values for each of the AI, you get all of your metrics. And then you also have false positives and false negatives nicely laid out to be consumed. Um, Bias and fairness, we talked about it. We have integrated the Equitas package. It is an open source package from the University of Chicago. Basically allows you to go deep into a few metrics. These are those metrics: equal parity, proportional parity, false positive rate parity, false discovery rate parity, false negative rate parity, and omission rate parity across these attributes that again you decide and you devise, and you can even upload data into the system and run it offline, right? Even if you've not run AI, you can upload those inferences, you can upload metadata, and you can use these tools on the platform as well. And then we have the bias report where we can go deeper into why they failed and so on and so forth. Um, and lastly, I promise, is the algorithm comparison. This is four AIs. Let's just see. These are three AIs. We can compare them. So you can, choose AIO1 here, AIO2 here, and then you can see, okay, for a false positive here, becomes a true negative on the right hand side. If you can see that blue, uh, you know, kind of dot is shining. So this is, just allows you to go further deeper into the analysis and review multiple AI side by side in the same idea. You can even view the ROC curve comparisons and so on and so forth. So now I am going to start taking questions. Um, wow, nice. So first is from my colleague Sarthi. He says, you keep saying that we help choose the best AI for you, but what do you do when a potential customer asks which one works best, or just help me pick one? Uh, Typically, Sarthi, as you know, we don't give an answer, right? We will still ask them for at least 100 scans. We will run them through the platform and build our own conviction and then show them the output. See, the reason we do this, one is to get to the right answer. The second is also to make the user part of the decision, right? Because at the end of the day, they are going to be the ones who either benefit or don't benefit from the algorithm, right? So that's why we push people, to use the validation platform and build that conviction around what to expect. Then we have a question from Gaurav. Gaurav has recently joined CARPL to lead up sales. His question is, what role do you see federated learning playing in the future of validation projects? I think federated learning itself, Gaurav, is just a way of creating AI. I don't think it has much to do with validation other than the fact that it will improve the performance of AI algorithms in general, right? Federated learning is essentially this idea that you have, five sites that have, say, 100 X-rays each. You create five different AI models at those five sites, and then you accumulate their weights such that you get a sixth AI model that works really well across all five sites. So federated learning is going to make validation more effective, I think, is what it's going to do. I would love to hear counterpoints if anybody has a counter argument on that. Next is from Shruti. Shruti runs Unboxing AI webinar series. Her question is, there's no universal benchmark for AI validation in radiology. Should there be a global standard for AI validation? And if so, who should define it? Regulators, professional societies, or industry consortium? Shruti, the way I answer that question is, of course, yes, right? There has to be some benchmarking, but just because you scored, just because you were top of class as a med student in a centralized examination does not mean you will get the job without an interview, right? An interview, and in our case, a validation study, is not only telling you about the performance of a particular AI system, it is also telling you about its drawbacks, about things it cannot do well, right? And that's what an interview is all about. So I would say, yes, there should be a universal benchmark for AI validation. We are part of many of those consortiums, but at the end, building that local conviction has to be a part of the AI utilization, at least the way I think of it. Next is a question from Senthan. External validation of AI models requires significant investment in infrastructure, high quality data sets, and expert oversight. Given these costs, how do you see the financial responsibility being distributed across stakeholders, AI vendors, hospitals, or perhaps independent third parties? Do you think there is an emerging business model that could support sustainable large scale AI validation? So, you are right, Senthan. It depends on how you define large scale, and it depends on, see, infrastructure and expert oversight are now getting commoditized. Like, with platforms like ours, we take care of infrastructure. You don't really need to worry about that. Uh, High quality data is a great point, right? Like right now, the only automated way of doing it is to go from text reports to findings, which is not ideal, but it is something. We have a bunch of features in the CARPL platform where, we can uh, search across data sets. We can pull from packs. We can do a bunch of things that makes it easier to get high quality data onto the platform. But you're right. I think the financial responsibility, in my very humble view, is going to be on the buyer, right? It's going to be on the user. The more you test, uh, the the better your interview process, the higher the likelihood that you get a good candidate, right? So I think it is going to be, of course, AI vendors will have to do their own published research, right? Here we are not, these are not research papers that we are trying to write. We are simply trying to say that before you go ahead and deploy even the world's greatest AI system, at least do a small validation study in-house to judge, what to expect in due course. So I know that's a bit of a controversial take, but that's me speaking from the heart. Um, Somebody who does not want to be named asks, it was mentioned that metadata level analysis can be done. Does that mean access to patient data is available on the CARPL platform? So DICOM metadata, and I'm just going to stop this, and DICOM metadata, and then metadata that you choose to upload. So you can upload a CSV, we can pull from HL7, we can do all those things. So yes, patient data, if you'd like it to come onto the platform, it can certainly come onto the platform for sure. Yes. Uh, then we have a question from Peter. Peter's the CEO of Occipit. Thank you for joining, Peter. Do you undertake post-market surveillance at predetermined intervals? How long after the initial procurement evaluation? Peter, every organization has their own guidance. What we've seen right now, for example, in Singapore, is 6 monthly surveillance, where we have to do a evaluation of retrospective data every 6 months. We have seen places in Brazil want to test out 5% of data randomly every month. So as of now, there is no mandate around the frequency. Our entire thesis is we are giving you the toolkits to make you, to enable you to be able to conduct whatever level of surveillance you want, right? We are giving you Microsoft Word, you write your own story in that sense. Then question from Vinod. Thank you, Vinod Kemal, for joining. Do you see a shift to foundational models, large vision models trained on multimodal data happening? How would CARPL adapt to that shift? We are seeing, we are working with some of the big companies out there that are building these models. Uh, for us, it would be an infrastructure shift, right? Not very different from what we're doing right now. We take data, give it to an AI model, get an output, give it back to the user. That flow would remain pretty much the same for us. There is a layer of radiologists building their own AI that we are working on. Happy to collaborate with the crazy enough people out there who want to try that out, where foundation models play a major role. So yeah, so I don't see us having to massively change what we are doing in that scenario. Uh, then we have a follow-up question from Sarthi. Can you give us the data to do this as well? Can you give us the data to uh, to determine which one works best? So if I was to give the data for a validation project at your institution, that would not make sense. And I get where your question's coming from, Sati. But yes, essentially, you need to test on your data, right? And thereby the data has to be yours. It has to be, it's difficult. Sometimes it's painful, but then if you want to get to the right answer, you have to put in that little bit more effort, is at least the thesis that we adhere to. I have a few anonymous questions here. We are at time. I'm just going to quickly uh, read out. How do we get a proper comparison between two algorithms, one which gives a probability score and another that gives a yes or no? Every algorithm is a yes or no algorithm because you have to draw a line in every algorithm. So the only difference would be that you would not get an AUC value for the yes no algorithm. You would still get sensitivity, specificity. Of course, there's an advantage to the probability algorithm that you can put the line wherever you want it. But regulation doesn't allow for that. Regulation fixes the threshold. So every algorithm is, unfortunately, at least today, a yes or no algorithm. What are the trade-offs between validating AI on site versus on cloud? Are hospitals realistically equipped to handle on-prem validation at scale? We equip them. If they are happy doing on-cloud validation, perfect. That works much easier for all AI companies out there. But it does generally mean at least 6 months more of filling out security questionnaires and just due diligence and BAAs and all sorts of forms, etc., which are bypassed by doing an on-prem validation. We provide the validation infrastructure. We will literally turn up with a box. Often it is me who turns up with a suitcase and a box in it and then puts it in your office. And thereby hospitals get realistically equipped to handle on-prem validation at scale. I like the integration of the Equitas for fairness and bias report. However, from models' predictive ability, do you have any methods to better understand how various models make their predictions given a specific image? However, from models' predictive ability, do you have any methods to better understand how models make their predictions given a specific image? I'm not able to get that question. Whoever it is, just feel free to write to me on LinkedIn or email. I will definitely get back to you. I don't know if you're talking about how on a single image different models give different outputs. If that's the case, it's a function generally of their training data. But would love to get this in more detail. Questions just come in from Senthan. I will take this as the last. Many AI models are validated for regulatory approval but fail in clinical practice. What are the biggest gaps between regulatory validation and real-world validation? Real-world data, real-world variability. Regulatory approval is a very intensely curated exercise. Um, the real world is not. The real world throws up surprises, and that's why we exist. So great, great that you would ask that question, Senthan. Thank you. That's a great ending point for this session. Uh, Validate your AI because there are gaps between regulatory, and we don't even get access to the regulatory studies, right? That's the other challenge. But there are gaps between regulatory validation and real world validation. So use CARPL and we'll help you figure it out. Thank you.